Okay, in this video, we're going to be taking a look at the second semester exam review that's in Delta Math. So let's take a look at this first question. It says to express the following fraction in simplest form using only positive exponents. So here I can show you we've multiplied 4a to the fourth and gotten 4a to the fourth divided by 20 times a to the ninth. When you have this same variable, you have a to the fourth divided by a to the ninth, you're actually subtracting those, 4 minus 9, which is negative 5. But if we were just looking at the variable a to the negative 5, we would move a to the denominator to make it a to the positive 5. So what we end up here is 4 over 20 simplifies to 1/5, and the a leaves, you have a to the 5th in the bottom. If you have 4 a's in the top and 9 in the bottom, 4 cancel out, you're left with 5 at the bottom, okay? So that's your final answer. All right, next one. So this one, you may see one similar to this, but this isn't one of the assigned ones on the assignment. But 3y to the 7th, all divided by 2y to the negative 2 power, all raised to the negative 5th. All right, so the first thing I want you to realize is in the denominator here, 2 to the negative 5th power, okay? In the denominator, we'll move that to the top into the numerator as 2 to the 5th power. And then the y to the negative 2 raised to the negative 5th, when you multiply negative 2 times negative 5, you get positive 10. So now we have a 3 times y to the 7th times 2 to the 5th in the numerator divided by y to the 10th. The y value, since we have 7 at the top and 10 at the bottom, we could do 7 minus 10, which is negative 3. That would be 3 y to the positive 3 in the denominator. And then at the top, all we have left is 3 times 2 to the 5th. That's 3 times 32, which is 96. So 96 divided by y to the 3rd would be our final answer. All right. In this one wants you to select an expression that is equivalent to 1 divided by 6x to the 1/2. Well, remember that your fractional exponents, the denominator of the fraction is the root power. So this says 1 divided by the square root of 6x to the 1 power. So 1 divided by the square root of 6x would be your answer. All right, in this one, we have, this wants us to identify the domain. We have a function, f of x equals 2x plus 9 divided by 4x plus 4. Well, in this function, this rational function, you cannot have a denominator of 0. So to determine the domain, it can be any x values as long as we do not have a 0, end up with a 0 in the denominator. So what we're going to do is we're going to set the denominator equal to 0. So 4x plus 4 cannot equal 0. We'll work it out like an equation. It says 4x equals to negative 4. Then we would divide by 4, and we see that x cannot equal negative 1, okay? And then these are the different ways that we could answer that, okay? We talked a lot about interval notation, negative infinity up to negative 1 with a union of negative 1 to positive infinity. Or we could just write it out like this. The domain is all the values x, all the real numbers for x as long as x is not equal to, and that's actually supposed to say negative 1. All right. Let's see here. Taking a look at this question. This says, again, find the domain. So we have f of x equals the square root of 24 minus 3x. Okay, well, in this kind of function, we cannot have the square root of a negative number. So what we're going to do is we're going to take this radican here, this 24 minus 3x, and we're going to set it equal to 0, or we're actually going to set it equal to greater than or equal to 0 and work it out like an inequality / equation. So 24 minus 3x greater than or equal to 0, we'll subtract 24 from both sides, so negative 3x greater than or equal to negative 24. Then when we're solving this, we have to divide by negative 3. So remember, when you're working with inequalities and you divide by a negative, you have to change the inequality symbol. So it went from this greater than to a less than. And then negative 24 divided by negative 3 is positive 8. So we know that our x value has to be less than or equal to 8 if we're going to get a positive value under the radical. So it's from negative infinity to 8 is how we would answer it in interval notation, or we could just say x less than or equal to 8. All right, now let's keep taking a look. So here we are, the next question. This one says to perform the following operation expressed in simplest form. So let me zoom in here a little bit. We have x to the third plus x squared divided by x squared plus x minus 56 times x squared minus 7x plus 28 divided by 4x. So what I'm going to do is I'm going to factor all of these, and we'll get our different factors, and then we'll start looking for common factors that would cancel each other out. So for instance, in this one, this x plus 8 in the numerator here and x plus 8 in this denominator will cancel each other out. Also, the x minus 7 in this numerator and the x minus 7 in this denominator would basically cancel each other out, and we would simply be left with the x squared times x minus 4 divided by 4x. And then in this one, if we're going to simplify that further, this 1x squared divided by 4x, that's going to become 1x over 4, so that one of the x's in the numerator of this x squared and this x in the denominator, x to the 1 cancel, we're left with 1 at the top. So that simply becomes x times x minus 4 over 4. All right, moving along. So this one here wants you to find the inverse function of f of x equals 6x plus 7. Okay, so if we're going to find the inverse function, what we're going to do is we're going to, first of all, the first thing we do is write it out as y equals 6x plus 7. Then to find the inverse, we're going to swap out the x and y. So now it says x equals 6y plus 7. Then we're going to solve for y. Well, we need to subtract 7 from both sides, so x minus 7 equals 6y, and then to solve for y, we would divide by 6. So the f inverse of x is actually equal to x minus 7 divided by 6. All right, next question. This one wants you to fully simplify this x squared divided by 5 minus x, all divided by x over 9 plus 1/3. All right, so the first thing we need to do is consider the numerator and the denominator, get some common denominators for each, and rewrite it. So in just the numerator here, we have a denominator of 5 and a denominator of 1. So this x is going to have to be multiplied by 5 over 5. The numerator and the denominator get multiplied by 5. That gives us 5x over 5. So we'll end up with x squared minus 5x all over 5. Then down here in this denominator of the original, x over 9 plus 1 over 3, the 9 and 3, what's in common there is the 9, so this 1/3 has to be multiplied by 3 over 3. So we end up with x minus 3 over 9. X plus 3 over 9. Well, now when we set these fractions, when we divide a fraction divided by another fraction, basically we multiply by the reciprocal. So this x squared minus 5x over 5 gets multiplied times 9 over x plus 3. Then we just multiply straight across. But as long as we're going to be simplifying, you can simplify first. This x squared minus 5x becomes x times x minus 5. And then that's 9 times x minus 5 over 5 times x plus 3. And there's nothing that cancels each other out, so that is actually going to be our final answer. All right, let's keep moving along here on this one. Here we have two fractions that are set equal to each other with variables in each of the fractions. So we're simply going to use our understanding of cross products. X plus 1 times x is going to be equal to x minus 6 times negative 4. So I've written that equation here, and then I just do the distributive property. I have x squared plus x on the left, then I have negative 4x plus 24 on the right. Then I'm going to combine all my like terms and set the equation equal to 0. So I have my x squared plus x on the left, this minus 4x. I'm going to have to add 4x to cancel it on the right, so I add 4x on the left. Same with the minus 24. I have to add, it's plus 24 on the right, so I subtract 24 on both sides, so minus 24. Set that equal to 0. Combine my like terms, x squared plus 5x minus 24 equal to 0. Now I can factor this trinomial. The factors of negative 24 that equal 5 are 8 and 3, or 8 minus 3. So x plus 8, x minus 3. Again, we set that equal to 0, the factors individually. So x equals negative 8 and x equals 3. All right, let's take a look at the next one. All right, so this question wants you to determine the feature of the graph of the given function. So here's our function, f of x equals 4x plus 12 divided by x squared plus x minus 6. First thing we're going to do is factor this and simplify it. So the 4x plus 12, we can factor to 4 times x plus 3. And then the numerator, or the denominator of x squared plus x minus 6 is x plus 3 times x minus 2. You'll notice that when we do that, we can cancel out the x plus 3 and the x plus 3. That means we have a hole when x equals negative 3. All right. And when we continue to simplify it, we end up with 4 over x minus 2. Okay. Now, when it asks for a horizontal asymptote, remember our phrase. The horizontal asymptote deals with the degree of the numerator and the denominator. If it is heavier on the bottom or big on bottom, then your asymptote is y equals 0. If the degree is higher in the numerator, so it's big on top, then there is no asymptote. That's what the n is. And then, of course, if they're the same, if the degree is the same, then you just divide the leading coefficients, okay? In this one, notice we have an x squared in the denominator and an x to the 1 in the numerator, so this is what we would call big on bottom. So this O, or this is the 0, y equals 0, that's our horizontal asymptote, okay? Now, the vertical asymptote is when we set the denominator, after we've factored it, simplified it, when we set that equal to 0. And in this denominator, we have x minus 2. So the 2 is what's going to give us a 0. So we'll have an asymptote at x equals 2. Okay, we can find the x-intercept when we set the numerator equal to 0, but when you have a constant, you put 4 equals 0, that is not true. So we actually do not have an x-intercept in this one. Again, if you want to find the x-intercept, you set the numerator equal to 0 and solve it. All right, now the y-intercept is when x is equal to 0. So if I plug 0 into this 4 over x minus 2, that would be 0 minus 2, which is negative 2, and that's negative 4 over 2, which is negative 2. So the y-intercept is at 0, negative 2. Then remember the hole. The hole was created, we realize the hole was created when x was equal to negative 3 because of this common factor in the numerator and the denominator that canceled out. Well, if the x is negative 3, you plug that in to your function, your final factored function here. So 4 over negative 3 minus 2, that's 4 over negative 5, or negative 4/5. So the hole is at negative 3, negative 4/5. And that is a review of features of the graph of this function, of a rational function. All right. Let's take a look at the last question for this part of the video review. All right, this question wants you to find the value of f of g of 8. And these are the given functions. Okay. So f of g of 8, and another way you might see it written is this f of g of 8. The first thing we're going to start with is the g of 8. Okay, so here's our function, g of x equals x minus 6. Well, if it's g of 8, we're just going to replace x with 8. So really, g of 8 is equal to 8 minus 6, and that is 2. Well, if g of 8 is 2, and we're finding f of g of 8, what we're finding is f of 2. So in this function, where f of x equals 3x squared plus x plus 12, we're going to replace x now with 2. So we have 3 times 2 squared plus 2 plus 12. And of course, 2 squared is 4. So 3 times 4 plus 2 plus 12, that's 12 plus 2 plus 12, which is 26. So the value of f of g of 8 is 26. And that'll end this part of the review.